Okay, today we're going to be dealing with fractional equations. Now this really starts to put together all the other things that we've been talking about throughout the year. In order to solve a fractional equation, what you really need to do, or what I recommend you do anyway, is cross multiply. Now, 90% of the time you say we're going to cross multiply, you're actually doing something that isn't cross multiplying. This time, however, we are involving a process of cross multiplication. And what you'll notice is that on both sides of the equation, I have factored forms of quadratic values. So as I expand using the distributive property, I end up with 3x squared plus 4x equals 6x squared minus x minus 2. All right, now what I'm going to do is combine like terms. What I need to do is get everything to equal 0. That way I can use several of the handy-dandy tricks that I've been practicing. So now I'm at 0 equals 3x squared minus 5x minus 2. Now I can go ahead and solve this quadratic. If you like, you can use the quadratic formula. You'll get the right answer first time, every time. However, in my infinite wisdom, I can see that 3x squared minus 5x minus 2 is something that could be factored easily using the cross method. If you're okay with guessing and checking and dealing with some ugly numbers from time to time, you can go ahead and use the cross method. However, if you don't want to guess and check, if you don't want to go back and forth with wrong answers, I highly encourage you to use the quadratic formula. Now I have my factored form as 0 equals x minus 2 times 3x plus 1. Alright, so that means I can set this up as x minus 2 equals 0 and 3x plus 1 equals 0. Because again, I'm looking for the values of x that make this equation all equal 0. So I have x equals 2 and x equals, let's see, subtract 1, divide by 3, x equals negative 1/3. So you might think that your answers are x equals 2 and x equals negative 1/3. But wait! We are dealing with fractional equations. Because we are dealing with fractional equations, what we need to do is take a look at the denominators of the equations. Because what we are seeing when dealing with a fraction, one of the most important rules is that your denominator cannot equal 0. Bad things happen when you have a denominator of 0. It means you're dividing by 0. It's end of days type things in the math world. We don't want that. So what we're going to do is check our answers. Here's how you do it. You take your two answers, x equals 2 and x equals negative 1/3, and we're going to plug them into our denominators. And that's how we're going to go ahead and check. Alright, so I have 3 times 2 plus 4. Does that combination equal 0? No, it doesn't. So far so good. I'm going to check the next one. 3 times 2 is 6 minus 2 does not equal 0. So far, x equals 2 is an okay answer. Now I'm going to check negative 1/3. 3 times a negative 1/3 is a negative 1 plus 4 does not equal 0. And 3 times a negative 1/3, which equals again a negative 1, minus 2, again, does not equal 0. And that's good. We do not want these values to equal 0. If we do, that means we have a denominator of 0. Again, bad stuff. So those are our two answers. Remember, when dealing with quadratics, you have the potential for either two answers, one answer, or no answer. Let's take a look at the next problem. We have 2 over x minus 2 plus x minus 3 over x minus 4 equals 2. The first thing I'm going to do is multiply everything by a common denominator. Everything, everything, everything. So in this case, my common denominator, taking a look over here, we could say this is the same as 2 over 1. My common denominator is going to be x minus 2 times x minus 4. So I'm going to go ahead and multiply everything by these values, which is going to look like 2 times x minus 2 times x minus 2 times x minus 4. It's going to look ugly here for a second. Plus x minus 3 times x minus 2 times x minus 4 over x minus 4 equals 2 times x minus 2 times x minus 4. Okay, I've multiplied everything by the common denominator of x minus 2 times x minus 4. Here's where the magic happens, because now what we're going to do is cross out our common terms here. Remember, just imagine this as over 1 if you can't see that's part. We have x minus 2 canceling out with x minus 2, and that leaves us with 2 times x minus 4. Now I'm going to take a look at the next term, and we see that x minus 4 cancels with x minus 4, and I'm left with x minus 3 times x minus 2, and sadly nothing cancels out on the right hand side, so that's going to be 2 times, why don't we go ahead and expand that, x squared minus 4x minus 2x, which is minus 6x, plus 8. Alright, so expanding further, I get 2x minus 8 plus, let's see, x squared minus 2x minus 3x is minus 5x plus 6 equals 2x squared minus 12x plus 16. Alright, it's getting uglier before it gets pretty, but that's okay. All we have to do is keep combining our like terms, keep going a step at a time. I know we are so tempted to just try and skip a lot of steps and do it all in our heads. Don't do that. There's a lot to carry here. You will make mistakes. And I'd rather you avoid mistakes. So let me combine positive 2 and negative 5x, which gets me a negative 3x. So I have x squared minus 3x. And then I'm going to combine a negative 8 and a positive 6. Minus 2 equals 2x squared minus 12x plus 16. All right, now that we're at this spot, we're comparing two quadratics. And what I'm going to go ahead and do is combine some like terms here. So I'm going to subtract x squared from both sides. I'm going to add 3x to both sides. And I'm going to add 2 to both sides. So what I'm left with on the left-hand side is 0, which is good. That's what I want. And now I have 0 equals x squared minus 9x plus 18. So again, I can go ahead and use the quadratic formula to go ahead and arrive at my answer. Or I might be able to see that x squared minus 9x plus 18 is really x minus 3 times x minus 6. That's okay if you can't see that right away. It's probably better to use a method, whether it's the quadratic formula, whether it's the cross method, to go ahead and arrive at your solution. Now I'm at 0 equals x minus 3, and 0 equals x minus 6. So I should see that my answer is either x equals 3 or x equals 6. But wait! I need to go back. Because I'm dealing with fractions, I need to check the denominators. So in this case, I'm taking a look at my two answers. Let's bring them back up. X equals 3 and x equals 6. And let's check them out. Let's see, 3 minus 2, that's okay, that doesn't equal 0. 3 minus 4, That's okay, doesn't equal 0. It doesn't matter that it's a negative number. I can have negative fractions. I just can't divide by 0. So 3 is okay. Now let's check 6. 6 minus 2 does not equal 0. 6 minus 4 does not equal 0. Both answers are okay. And there you have several examples. The idea here is to take what you've been learning over the past couple of months and apply it in a variety of different situations. It isn't about memorizing a specific process because everything's going to be different. So that means if you're a little confused or if you're not sure which step to use when, practice, practice, practice.